A ball is kicked with an initial velocity of 10 meters per second at an angle of 40 degrees above the horizontal. What is the peak height of the ball, and what is the distance traveled by the ball when it hits the ground, which is from here to here? Now, first we need to resolve the velocity of the ball, which is 10 meters per second, into its vertical and horizontal component. Now, it's easier to draw this in a right triangle so that it's easy to solve using trigonometry. So this is your hypotenuse at 10 meters per second. So your vertical velocity is opposite of the angle. So opposite over hypotenuse is sine. So sine 40 is the vertical component divided by the hypotenuse, 10 meters per second. So multiplying 10 meters per second on both sides, we will have the vertical component is equal to sine 40 times 10 meters per second. So sine of 40 degrees is equal to 0.6428 times 10 meters per second is 6.4. So this is the vertical component, 6.4 meters per second. To solve for the horizontal component, so this is your angle, this is adjacent to the angle. So this is the horizontal divided by the hypotenuse. This is cosine 40. So cosine 40 is Vx divided by 10 meters per second. So to remove this 10 meters per second, we have to multiply both sides by 10 meters per second. We will have the horizontal component at cosine 40 times 10 meters per second. Cosine 40 is equal to 0.766 times 10 meters per second. So your horizontal component, horizontal velocity is 7.66 meters per second. Now we can use the vertical component to compute for the peak, the height. If you can compare if the ball has a vertical velocity of 6.4 meters per second, it is the same as the ball which has a 40 degrees angle, but the vertical component is also 6.4 meters. So if you release that, they will be reaching the same height. So we can use only the vertical component to get the height of the peak height of the ball. So using this equation, final velocity squared is equal to the initial velocity squared plus 2 times acceleration due to gravity times the distance. Now, when the ball is reached the peak, the final velocity at that point is 0 because it will start to go down again. So the final velocity will be 0, but the initial velocity will be 6.4 meters per second. So just plug in the values. So plus 2 times negative 9.8 meters per second squared times d. This is negative because it's going up is decelerating. It's slowing down. It will start fast and then it slows down until it reaches 0. So since this is negative, we can transpose it to the left side. So it becomes now positive. 2 times 9.8 meters per second squared times d is equal to 6.4 meters per second, the quantity squared. So 2 times 9.8 meters per second squared is 19.6 meters per second squared times d. So 6.4 times 6.4 is 40.96. So the units is also squared. It will be meters squared per second squared. Now we are looking for d, so we need to divide both sides by 19.6 meters per second squared. So this becomes d is equal to 40.96 meters squared per second squared divided by 19.6 meters per second squared. So this one divided by this one will be approximately 2.1 meters. This will be the peak height of the ball. Now we can also use the vertical component of the velocity to compute for the time for the ball to reach the peak. Now we can use this formula. Final velocity is equal to initial velocity plus gt. So initial velocity, of course, is still 6.4. It will start at 6.4, and then by the time it reaches the top, the final velocity would also be 0. So the acceleration due to gravity is negative 9.8 meters per second squared times the time, which at this point we don't know yet. So since this is negative, we can transpose it on the left side. It becomes positive. Now we are looking for the time, which is multiplied to 9.8 meters per second squared. So we divide both sides by 9.8 meters per second squared. So 6.4 divided by 9.8 is 0.65. Meters per second divided by meters per second squared, your final unit will become second. Now, this 0.65 seconds is only the time from the start up to it reaches the top. Now, the time it requires to go up is the same time it requires to go down. So we multiply it by 2. So the total time that the ball is in the air is 1.3 seconds. Now, we need to compute this time because we need to compute for the distance from here to here, and then we need the time that is in the air to compute for the distance. Now, the horizontal component, which is 7.66 meters per second, this is constant, going to the right, going in one direction. So we can compute the distance using this velocity, and with the time that we have 1.3 seconds, we can compute for the distance. So distance is velocity times time. Now we can now substitute the horizontal velocity, 7.66 meters per second, times the time, which is 1.3 seconds. So 7.66 times 1.3 is approximately 9.958 or 10 meters.